Hello everyone, and thank you very much to our EclipseCon 2020 talk. I'm JJ Billings. I'm a member of the staff at Stellar Science Limited Company and the project lead for the Eclipse ICE project. And I'm joined today by Daniel Bloom from Oak Ridge National Laboratory, who is a committer on the Eclipse ICE project. We're going to talk to you today about some work that we've been doing to create a simple code generator for data models, web forms, and scientific workflows in Eclipse ICE. So let's go ahead and jump into this. And my goal today is to convince you to start automating your code development. I'm not actually trying to convince you to use Eclipse ICE or to even necessarily try it out, although I do have a slide on that. My real goal is to show you how easy it is to set up your own code generator in your own project. And I'm going to do that by showing you an example of what we've done in Eclipse ICE. So let's go backward. Let's work backward through this problem. So I'll start by telling you what Eclipse ICE is. And this is pretty simple, actually. So Eclipse ICE is it's about 10 years old. Oak Ridge National Laboratory joined the Eclipse Foundation in 2014, and when the laboratory joined, this project was proposed at the Eclipse Foundation and picked up. And it's changed a little bit over time, and now we're building a third version of this software. And the whole point of this project is to create workbenches and workflow management systems and to make it really easy to do that. So the core idea is that ICE sits between users, depicted here by an old picture of me in a pirate hat, and systems, input systems, supercomputers or clusters or what have you, output systems, storage systems, and development environments. Most of the stuff that we do in scientific workflows can be automated and encapsulated if we just think about it a little bit. So here are some examples of what we can do in ICE, and I'm going to turn these videos on. Hopefully they play inside the recording. I don't know how well that will work. But let me show you some of the workbenches and workflows that we've enabled. Starting with number one in this picture, this is an analysis workbench that we built for looking at sodium-cooled fast reactors. Moving to number two in the top middle, we built a workbench for looking at neutron reflectivity. And in the third spot on the top row was a visualization engine that we built. It was also for looking at sodium-cooled fast reactors, but it was a different type of plugin for the platform. In the number four spot down here, this was for looking at what are called trisoparticles in molten salt reactors. In the middle, this is actually a computational battery environment that helps a lot of different companies simulate batteries, in this case a rolled up or an AA type battery. And then we have a 3D printing workbench at spot number 6. Spot number 7 is another nuclear reactor example looking at a light water reactor. Spot number 8 is looking at a balance of plant calculation with the flow around, in this case, a boiler powered by nuclear energy. And number 9, this is looking at some phonon scattering data for inelastic neutron scattering. So this is a sample of the types of workbenches that we can create, but we've done a lot of different types of workbenches for astrophysics or quantum computing, all sorts of other interesting things in the advanced materials area. And the goal is to make this easy. These pictures are from ICE 2, and with the new version, we want to do this on the web in just as simple as a way. So what are workflows then? I keep mentioning these workflows, and what are these things? So scientific workflows can be thought of best by splitting them into 4 camps. There are high throughput workflows, conceptual workflows, optimization, and modeling and simulation. So what does this really mean? Well, high throughput workflows are just about data. So if you have a lot of data that you need to process and you're running many workflows back to back just to process that data, possibly in parallel, those are high throughput workflows. Conceptual workflows are about processes. So if you have a process and you're sketching out how that process works, then that's likely a conceptual workflow. Optimization is about doing surveys and mini reruns to optimize a particular outcome. And modeling and simulation is, well, it's about modeling and simulation. There's not really a better way to say that, but that is where we're using simulations to study the behavior either of existing systems or systems that don't exist yet. So when we're talking about web forms and data models in this project, here's a cartoon of what that looks like. This is an old pattern, it's nothing new. There's some form, which is to say some website that takes data entry at frontend.example.com. So whatever that web form is, it's at example.com, and the user puts in some input and hits go. There's a server sitting at backend.example.com, and then there's a database where this goes. If you want to run this in a desktop application, it's the same thing. It just becomes model view controller, and you have a view that talks to controllers and talks to the models. So this is what we're talking about when we're talking about web forms and data models. So for forms and workflows in Eclipse ICE, we have a number of requirements. In fact, we have a lot of requirements. Some might say we have more than we need, but the truth of the matter is that to put a workflow in front of a user so they can edit it, or to give them forms for processing requests from web pages, there's a lot of stuff that you need. The user just wants to have, or the client, user or the client, needs a class with some data members. Those could be strings like where they want to go to buy something or where they're getting their pizza from. In our case, in science, that's often things like temperatures and pressures and densities. But Java needs some stuff in addition to that, and the framework needs even more. So Java needs things like equals and clone and hash code and toString. And these are really for collections. Arguably, toString is used in some other contexts as well as the others, but really this is about putting things in collections and making sure that you can move them around okay. But the framework needs all of these other things. For the UI and for a workflow, you need names, descriptions, IDs, etc. And for persistence, you need from string, if you want to read in from a string. You need other tools for reading to and from JSON and things like that. So for the web form example that I just showed you, and then for the examples before that, just to put those on the screen, there's a lot of information we need to get in addition to what's the value in this cell. So the problem with this is that it's just too much time to re-implement all of this by hand. Now for a single user, this is probably okay. They're going to do it once. So they're going to hire someone and that person's going to do it, and then they're going to maintain it a little bit, once every few weeks or so. When there are some updates to Next, they're going to go in and update it. It's no big deal. But for the dev team, this is like Groundhog Day. If you don't know what Groundhog Day is, it's a US holiday where Groundhog comes out and sees its shadow, but where this saying comes from is a movie where the main character, played by Bill Murray, just repeats the same thing over and over again. And he lives through Groundhog Day over and over again. And for developers, if you have all of these requirements and you just spend all your time re-implementing them, it can really feel like all you're doing in your career is repeating yourself. And that makes things difficult. It makes things difficult from the perspective of doing something new. It makes things difficult from the perspective of supporting the project, just to maintain it and keep it going. So there are some solutions. In ICE 2.0, we used an encoding and inheritance scheme to get around hard coding and things like that. The Eclipse modeling framework is an excellent solution. You can also use other types of meta models like the resource description framework and ontologies, then generics, and annotation processing. I want to go through these pretty quickly because we've tried all of them and we chose annotation processing. So for encoding, inheritance, and RDF-AL, all of these different ways of encoding the information are equivalent. I want to direct your attention to this middle box here because this is how we did it in ICE 2.0. We had an entry class, and you would fill that entry, and you'd tell us your type and things like that. And in RDF, it's the same thing. You have a model, and you fill that model up. Now, the problem with this is that users have to conform to these very tight models. A change in the model impacts all the clients, and there's lots and lots of maintenance. So that wasn't ideal. We did that for about 8 years, and it's really quite painful. We wanted something better. So the next solution that we tried after RDF and OWL, which was the second solution, the next solution was to use generics. This is a very awesome solution. It's super easy. It separates the user and the client class T inside the container, and it puts the framework logic on the container. Now, I'm using container here to describe the generic, but in this case, the generic data element acts like a container that wraps the client class T. Now, the problem with this is that it puts requirements by convention on T. So you can see in the example up here, there's T extends serializable. So now there's a requirement by convention that T has to be serializable. There are further requirements throughout this generic, and this is the actual generic that we used, and in some cases we still use, and it puts requirements on what clients need to do. So if the data element generic is going to realize toString, T also needs to realize toString or implement toString. And then there are too many choices. Do you use the container as a data element? Do you specialize it as my data element? So these are tough choices, and they make for a lot of confusion. The Eclipse modeling framework is a fantastic solution. If you can use the EMF, go use the EMF. In our case, we couldn't use it for ICE 3 because we're not an OSGI project. We're not using anything from RCP. We're just straight Maven and using web technologies. So the EMF was not a good solution for us, but it is a fantastic solution for almost any other project. And the way this works is you create a model and it generates about 90% of the code all the way up to the UI. It's a very great tool. We've used it on a number of different things, and I would recommend that you check it out. So for annotation processing, so if you've ever seen @override in Java, that's an annotation, and that annotation gets processed by the compiler. Here on the right, you can see we have @dataElement and @persisted. This is a way to allow users to provide metadata about classes and information that they want to share with the developers, so the developers can react to those annotations and process them. So the interface is a marker, annotations are just implemented as interfaces, and the annotations are processed by these annotation processors that extend abstract processors. There's a lifecycle. The developer applies an annotation, the compiler reads that annotation, and then it loops until it processes all the annotations, and then it ends. There are some limitations. You cannot generally edit a .java source file. You have to write a copy of that file, which is why you can see person spec, and we'll come back to that in a little bit. And you manipulate types using something called type mirrors. And generally, the annotation processing framework feels a little half-baked or not fully baked. There's a lot of stuff that seems like it's missing, and it's got a kind of an odd lack of frameworks to support it. But otherwise, it's pretty awesome. So in ICE 3, I'm going to tell you how we're using annotation processing to solve this problem of ours. The goal is to reproduce what we have in ICE 2 with data structures. You remember I showed you that slide where we had all these logically equivalent things, but they're just kind of too hard to maintain. We want to make it easier, of course, more maintainable. We want to do this outside the OSGI and the RCP, and we want to cut down on our dev time and support. So if we go back to this slide with requirements, we couple annotation processing with templates and bytecode manipulation to meet all of these requirements. So everything on this screen we can meet using annotation processing, and we mix some other stuff in. The client workflow is pretty simple. They run an ICE project generator. We don't want them to have to configure all the details of this project on their own, so they run a generator. And that generator then gives them an area where they can create a spec class, a specification for what we should generate. And this is a model. And then we go through and generate the code once they apply the annotations, and they can just keep working on this code as they normally would until they're done and it ends. The annotations that we have available, we have data element, data field, and some default values that you can set, persisted in web form. Now these are all, you're going to see a demo of these in a minute, and it'll show you how these work. Coming soon, we're going to have an aggregator. So data element is the basic annotation to convert a spec into an ICE3 POJO. Data model will be an aggregator for that. Okay, let's get to this demonstration. Daniel's going to show you how this is done.
This is a short demonstration of generating web forms with Eclipse ICE 3. So on the right side of my screen here, I have a couple of data elements open, and on the left side of the screen will be our demo web app. As you can see, the server is currently inactive. So the person spec I have open here is contained within one of the dependencies of our test project, and the one next to it, this car spec, is contained within the test project. So I'll go ahead and jump into it and generate a web form. So I'll do this by triggering a Spring Boot run, and this will be a minute. Okay, now that that's running, I'll refresh the page. And here we are. So it's not too pretty at the moment, but here we have a form clearly labeled with person, with all the fields found on our person data element. All of these, the ID, name, description, these are all common to all data elements, but after those we see the fields that are specific to the person data element, the age, first name, and last name. Since this is of course a form, we can edit these fields and watch the other elements bound to the same values update in real time. So this label here is bound to the name field of our data element, so if I change this we can see it update there as well. Same with the description, this little blurb below it, I can modify that. And then below the form I'm also showing the raw JSON representation of our data element as well, and we can watch our person-specific values change here as well. And then below the person form, I have a car form. It's same story here, just with cars pretty much. But this one is different because it's being generated from the test project itself rather than from one of the dependencies. So we have our person spec here, but what happens if our dependency updates and now the person data element now has an additional field? So let's say we want to add an occupation with a default value of unemployed. So I'll add those in real fast. So now if we go ahead and build the dependency as well as rebuild our test project, we should see this form regenerate. So I'll trigger a rebuild on this project. And now that that's been rebuilt, I will rerun the test project. So now if we refresh this page, we can see that the person form has been updated with the new field, and just like all the other fields, we can modify this value and see it change below. So we can do the same thing with data elements defined within our test project. So we'll go over here to the car spec, and let's just add a quick field for the trim level. Okay, and if we refresh the page one more time, our person form is still the same, but we can see that our car has now been updated with the new trim field, which is again editable and everything. And there we go. That's our form regenerated, adding that new field. So what's going on behind the scenes here? So these forms are currently being generated by reflecting TypeScript models of our data elements. During compilation, while all the boilerplate of our data elements are generated, a TypeScript model is also generated and packaged into the jar in a discoverable location. Our test project then, using a Maven plugin, checks its dependencies for TypeScript files at this location, and then can pull them into the front-end files of our project for our use. A similar process is occurring for the data elements defined within the test project. A TypeScript model is generated, and using a Maven plugin, the generated file is pulled into the front-end files of the project again. Form generation by reflecting these models is our proof of concept, but eventually we'd like to generate entire forms with our annotation processing framework that can be composed of data elements or can have their own independent fields not tied to any other object. These forms can then also have actions defined in Java for handling submission and other events using the task and hook framework that Jay has put together. So that's where things are right now, and we're excited for the next steps. That's all I've got. Thank you.
Okay, so what you just saw, how did we do it? We combine a few technologies to make this work, and you can reuse all of these on your own project. These are all open source, and even the pieces that we've built in ICE, if you want to try reusing those, they're open source as well. So we combine our annotation processors with Apache Velocity for template processing, Lombok for bytecode manipulation, Vaadin and LitElement for web form generation, and Maven archetypes for project generation. So our annotation processing tools are really lightweight. It's about 10 to 15 classes, and all the generated classes, so every spec that someone creates, ends up generating classes that realize the same interface. The person spec that you saw in Daniel's video and in some of the earlier examples generates a person interface. The person interface extends the iData element interface, and that person interface is then implemented by a person implementation. This is classic, just abstract base class stuff. It's object orientation 101, but it gives us a uniform interface across all of our data elements. And so that's the basic design. And so going from there, how do we actually generate the code, the client code that makes this work? So we use Apache Velocity templates. And this is a very old way of doing this in Java. There are a lot of videos out there where you can check this out, and a lot of videos, a lot of guides on the internet. I'd be happy to point you to some. What makes Apache Velocity the choice for this is that Apache Velocity is integrated very well with Java, and you can do callbacks and work directly with the generation framework. And templates are a very good solution for us because we know exactly what we want for the framework in ICE. We know what we want our JSON operations to look like. We know what we want descriptors and universal IDs to look like. Now, Lombok is an interesting tool that actually manipulates Java bytecode. So when I said you can't manipulate a Java class directly, you can in fact change the bytecode, and Lombok does this by exploiting some holes in the JVM. It generates most of the boilerplate that Java needs. So we use Lombok to create equals, copy clone, hash code, toString, and it also produces some very handy builders. So we use Vaadin and LitElement. I'm not going to say a lot about it. It's just a super awesome web framework, and we use it. And I recommend everyone check this out. It happens to couple very well to Java because you write in Java and it transcodes into TypeScript or JavaScript. And one of the things that we did in this talk is we showed you a very simple example, but you can customize this car example to make it look a lot better. And we didn't do that here. We wanted to focus on the basics of this, but Vaadin is a very powerful platform for doing this. Maven archetypes are really great, and in this case where we have so much stuff that we're doing and configuring, we made some project generators to get around this. And that way, if you look at the demonstration that Daniel did, you can see that we generated those projects and we just ran regular Maven builds on them. So here's an example of how this works in the wild. So @data element can be loaded using a JSON file. So we made a utility that will read that in. And so for some Neutron data JSON files on one of the projects at Oak Ridge National Laboratory, they've actually used this to read in their entire JSON schema for one of the reduction codes, and it generates all the classes. Now what's really awesome about that is they can automate that in the build, and it runs in less than a second to generate all that code, whereas writing it by hand would take the developer weeks and then, if not months, to maintain it throughout the life of the code. Example 2 is ICE itself, where we greatly accelerated development by using Spec classes in ICE 3 as we've been building it. This is an example of one in the tasks framework, and we're using more as well. We have them in tests. They're very handy for test classes where you can just spin up a test class quite quickly. So if you want to try it, I would direct you to the README in our next branch at our repo. So we are at github.com/eclipse/ice. If you go to the next branch, you can check out the README. And if you have feedback, we prefer feedback in the form of a pull request in lieu of complaints. But of course, you can email me directly, and I'd be very glad to answer your questions, or you can reach out on Twitter. So there's some other really cool things in ICE 3 that I don't have time to talk about, like overhauling our commands package for local and remote execution. Our new workflow API is really great, and it allows us to integrate with other workflow engines, and I'd be happy to tell you about that. We're working on being cloud native so that we will run natively on the cloud without any desktop service frameworks, and integrate directly with in particular function as a service platforms like Lambda. So my final thoughts on this: there's no magic here. Someone has to write the code. Something has to write the code. And I would just prefer that it's not me. It takes a long time to implement equals and to test it. And then you really kind of wonder, how long have I been doing this in my career, and how much coffee have I missed? How much of a good cup of joe with a friend have I missed out on? We tried to do this in a very lightweight way that was in source, so we didn't lose track of our models. And it has a very simple implementation. If you know how to use annotation processors, our implementation is pretty simple. There's plenty of room for improvement, but the whole point is that this can bend the developer time curve on just about any project. So I hope this has convinced you to check out code generation for yourself. If you have any questions, feel free to reach out. We'd be very glad to talk to you about it. Thank you very much for attending our talk, and please join the conversation on Twitter at EclipseCon or #EclipseCon. Thanks again for attending our talk and for coming to EclipseCon 2020. And I encourage you to evaluate the sessions. You can sign in at eclipsecon.org. And I hope that you like this talk and will give us a +1. Thank you very much. We'd love to take your questions. All right. Hello, everyone. I hope you can hear me. Let me know in the chat if you can't. There is a question here. How is the performance portability of the bytecode generator? We have not had any problems with portability. It builds on everything we've tried, and performance seems to be quite acceptable. Are there any other questions? We only have maybe a minute or so left, so not seeing any other questions in the chat. What I would recommend is that if you have questions, then please reach out through Swapcard. So you can send a chat in Swapcard. And the other way to reach out is on Twitter. I'm on Twitter at JJBillings. You can also go to the Eclipse ICE repo, and there's information there on how to connect with us. Thank you very much. It's been a pleasure.